Shunts are electrical components that provide a parallel path for current to flow, bypassing the main electrical circuit. In a 208-volt three-phase panel, shunts are typically used for current balancing. Shunts ensure that current is evenly distributed across all three phases, minimizing voltage imbalances and reducing neutral current. Shunts can also be used for arc fault detection. Shunts can be wired with arc fault circuit interrupters, or size, to detect and interrupt electrical arcs, which can cause fires. Voltage monitoring is another application. Some shunts incorporate voltage sensors to provide monitoring and disconnect protection in case of overvoltage or undervoltage conditions. The purpose of shunts includes improved power quality. By balancing current and reducing voltage imbalances, shunts enhance power quality and extend the lifespan of electrical equipment. Shunts also offer increased safety. Arc fault detection and voltage monitoring enhance electrical safety by preventing fires and potential damage to equipment. Code compliance is another purpose. In some jurisdictions, the use of shunts in 208-volt three-phase panels is required by electrical codes to meet safety and power quality standards. Shunts are typically installed on the line side of the panel in series with the main disconnect switch. They should be sized and rated for the specific application and electrical system requirements. Regular maintenance involves visual inspections and occasional cleaning to ensure proper operation. Understanding the role of shunts in a 208-volt three-phase panel is crucial for electrical professionals. These components play a significant role in maintaining power quality, ensuring safety, and adhering to electrical codes. Let's delve deeper into each of these aspects. Firstly, current balancing is a primary function of shunts. In a three-phase system, it's essential to distribute the load evenly across all three phases. Uneven loading can lead to voltage imbalances, which can negatively impact the performance and lifespan of electrical equipment. Shunts provide a parallel path for current, allowing it to flow more evenly across the phases. This helps to minimize voltage imbalances and reduce the neutral current, which can cause overheating and other problems. Secondly, arc fault detection is another important application of shunts. Arc faults are unintentional electrical discharges that can occur when insulation breaks down or connections become loose. These arcs can generate a significant amount of heat and can easily ignite nearby materials, leading to fires. Arc fault circuit interrupters, or size, are designed to detect these arcs and quickly interrupt the circuit, preventing a fire from starting. Shunts can be wired in conjunction with a size to enhance their effectiveness. The shunt provides a low impedance path for the arc current, making it easier for the FSI to detect the fault and trip the circuit. Thirdly, voltage monitoring is another function that shunts can perform. Some shunts are equipped with voltage sensors that continuously monitor the voltage levels in the panel. If the voltage exceeds or falls below a certain threshold, the shunt can trigger a disconnect protection mechanism, shutting down the circuit and preventing damage to equipment. This is particularly important in applications where sensitive electronic equipment is used, as overvoltage or undervoltage conditions can cause malfunctions or even permanent damage. The benefits of using shunts in 208-volt three-phase panels are numerous. Firstly, improved power quality is a major advantage. By balancing current and reducing voltage imbalances, shunts help to ensure a stable and reliable power supply. This can improve the performance and extend the lifespan of electrical equipment, reducing downtime and maintenance costs. Secondly, increased safety is another key benefit. Arc fault detection and voltage monitoring help to prevent fires and protect equipment from damage. This can create a safer working environment for electrical personnel and reduce the risk of accidents and injuries. Thirdly, code compliance is often a requirement for using shunts in 208-volt three-phase panels. Many jurisdictions have electrical codes that mandate the use of shunts to meet safety and power quality standards. By installing shunts, you can ensure that your electrical system is compliant with these codes, avoiding potential fines and penalties. When it comes to installation and maintenance, there are a few key points to keep in mind. Firstly, shunts should always be installed on the line side of the panel in series with the main disconnect switch. This ensures that the shunt is able to protect the entire panel from faults and overvoltage conditions. Secondly, shunts should be sized and rated for the specific application and electrical system requirements. The shunt's current rating should be high enough to handle the maximum current that the panel is expected to draw. The voltage rating should also be appropriate for the system voltage. Thirdly, regular maintenance is essential for ensuring the proper operation of shunts. This includes visual inspections to check for any signs of damage or wear, as well as occasional cleaning to remove any dust or debris that may have accumulated on the shunt. By following these installation and maintenance guidelines, you can ensure that your shunts are performing optimally and providing the benefits that they are designed to deliver. In summary, shunts are essential components in 208-volt 3-phase panels. They provide a parallel path for current, helping to balance the load across the phases, detect arc faults, and monitor voltage levels. By using shunts, you can improve power quality, increase safety, and ensure code compliance. Proper installation and maintenance are crucial for maximizing the benefits of shunts. Now, let's talk about the specific scenarios where shunts are most beneficial. Firstly, in commercial buildings with a high concentration of electronic equipment, such as computers, servers, and other sensitive devices, shunts can help to protect these devices from voltage fluctuations and power surges. This can prevent data loss, equipment malfunctions, and costly repairs. Secondly, in industrial facilities with heavy machinery and equipment, shunts can help to improve power quality and reduce downtime. Voltage imbalances and harmonic distortion can cause equipment to overheat and fail prematurely. Shunts can help to mitigate these problems, extending the lifespan of equipment and reducing maintenance costs. Thirdly, in healthcare facilities, shunts are particularly important for ensuring the reliable operation of critical medical equipment. Power outages and voltage fluctuations can have serious consequences for patients who rely on this equipment. Shunts can help to prevent these problems, ensuring that medical equipment operates safely and reliably. In addition to these specific scenarios, shunts are also beneficial in any application where power quality is a concern. This includes data centers, telecommunication facilities, and any other location where a stable and reliable power supply is essential. When selecting shunts for a 208-volt 3-phase panel, there are a few factors to consider. Firstly, the shunt's current rating should be high enough to handle the maximum current that the panel is expected to draw. It's always better to err on the side of caution and choose a shunt with a higher current rating than you think you need. Secondly, the shunt's voltage rating should be appropriate for the system voltage. In a 208-volt 3-phase system, this shunt should have a voltage rating of at least 250 volts to provide a safety margin. Thirdly, the shunt's accuracy should be considered. The accuracy of the shunt will determine how accurately it can measure current and voltage. For most applications, an accuracy of plus or minus 1% is sufficient. Fourthly, the shunt size and mounting configuration should be considered. The shunt should be small enough to fit comfortably inside the panel and should have a mounting configuration that is compatible with the panel's design. Finally, the shunt's manufacturer should be reputable and have a proven track record of producing high-quality products. Choosing a shunt from a reputable manufacturer will help to ensure that the shunt is reliable and will perform as expected. Once you have selected the appropriate shunts for your 208-volt 3-phase panel, it's important to install them correctly. The installation process will vary depending on the specific type of shunt that you are using, but there are a few general guidelines that should be followed. Firstly, always disconnect the power to the panel before installing shunts. This will prevent electric shock and ensure your safety. Secondly, follow the manufacturer's instructions carefully. The manufacturer's instructions will provide detailed information about how to install the shunts correctly. Thirdly, use the appropriate tools and equipment. Using the wrong tools or equipment can damage the shunts or the panel. Fourthly, double-check all connections to ensure that they are tight and secure. Loose connections can cause problems with power quality and can even create a fire hazard. Fifthly, test the shunts after installation to ensure that they are working properly. This can be done using a multimeter or other testing equipment. After the shunts have been installed and tested, it's important to maintain them properly. Regular maintenance will help to ensure that the shunts continue to perform optimally and provide the benefits that they are designed to deliver. The maintenance process will vary depending on the specific type of shunt that you are using, but there are a few general guidelines that should be followed. Firstly, visually inspect the shunts regularly to check for any signs of damage or wear. Look for cracks, corrosion, or loose connections. Secondly, clean the shunts periodically to remove any dust or debris that may have accumulated on them. Dust and debris can interfere with the shunt's ability to accurately measure current and voltage. Thirdly, test the shunts periodically to ensure that they are still working properly. This can be done using a multimeter or other testing equipment. Fourthly, replace the shunts if they are damaged or worn. Damaged or worn shunts can compromise power quality and can even create a safety hazard. In conclusion, shunts are essential components in 208-volt three-phase panels. They provide a parallel path for current, helping to balance the load across the phases, detect arc faults, and monitor voltage levels. By using shunts, you can improve power quality, increase safety, and ensure code compliance. Proper installation and maintenance are crucial for maximizing the benefits of shunts. By understanding the role of shunts and following the guidelines outlined in this discussion, you can ensure that your electrical system operates safely and reliably. The world of electrical engineering can be intimidating, especially when dealing with complex systems like 208-volt three-phase panels. However, by breaking down the components and understanding their functions, you can gain a solid grasp of the subject matter. Shunts, as we've discussed, are just one piece of the puzzle, but they play a vital role in ensuring the safe and efficient operation of electrical systems. Remember to always prioritize safety when working with electricity. Disconnect the power before performing any maintenance or repairs, and always follow the manufacturer's instructions carefully. With the right knowledge and precautions, you can confidently navigate the world of electrical engineering and contribute to the safe and reliable operation of electrical systems. As you continue your journey in the electrical trade, remember to always stay curious and keep learning. The field of electrical engineering is constantly evolving, with new technologies and techniques emerging all the time. By staying up to date on the latest developments, you can ensure that you are always providing the best possible service to your clients.